of moment generating function. Now take a look at part 2. Okay, in the part 2 here, the MGF of a random variable S is this. What is that? Which moment generating function? Can someone tell me which random variable has this as a moment generating function? That's Poisson. Good job. Okay, now I'm gonna give you that way, like, okay, you have this. The question now says show that the probability of S line between this is this. If I want to show this, you can see that inside the parentheses here, I got mu and sigma. I need to four of us come here and derive what does it mean, what is the the variance. And let me tell you this. When you want to talk about you just said Poisson right now. So for Poisson is T is this minus 1. This is a moment generating function of Poisson. If I were you, if it is on Poisson, I think I've derived in this class, okay, expected value of X is mu. The variance of X is also, I think, mu. Yeah, the variance, the mean and the variance in Poisson should be the same distribution. Now, what is acting as a mu here? 4. Do you understand now? It means 4 equal to 4 is mu, and if it's mu is 4, the variance also 4, then the standard deviation will be 2. Now, here 4, you plug in 4 minus 2 times 2. This is going to be 0. Okay, that was why you have this 0. Okay, if you plug in that, now what you now want to do now is you want to find that this guy now, the fact that you've recognized the distribution. Okay, now this is what you want to find now. The probability of S lie between 0 and 8. That's what you want to find now. And the probability of S lie between 0 and 8 is the same thing as finding the probability of S less than 8 and that. Okay, and less than 8, because Poisson is a discrete. Okay, because Poisson is discrete, right? Less than 8 will mean you want to talk about 0 to 7. Less than 8, we're talking about discrete. So that's going to be this. So what I'm trying to say is that this guy, because I'm talking about discrete, is going to be S less or equal to 7. And S less or equal to 0 will strictly be S equal to 0 for Poisson. Okay? Now, since I didn't teach arrow in this class, so you can ignore this guy. This is how to use arrow to do that, but you can ignore that. But what you need to do here, okay, I'm actually going to provide tables in exam. If you want to go manually, if you want to use table, I'm going to make sure I provided. If I'm going to ask a question on Poisson, there's a Poisson table, okay? And we also have an online calculator for Poisson as well, okay, which I'm going to walk you through tomorrow if you don't want to go through. Otherwise, you're actually going to use the formula for Poisson, which is the probability of this is this, mu raised to power x over x factorial. So you want to find probability of x less or equal to 7 now. Okay, that is going to take forever because you need to come here and do summation s start from 0 to 7, e raised to power 4, 4 raised to power s over x factorial. You need to do this. That may take your time. Okay, that's why I'm gonna walk you through in tomorrow's review. I'm gonna walk you through how to use either a table or online calculator, which I'm going to allow to use in the exam. Does that make sense? Okay. Now with that, you're actually gonna get that. I'm done. Now a whole question. I'm confirming to you this is there's gonna be a question centered on moment generating function. Okay, in the first one they're going to mention the distribution. You are going to be the one that will figure the moment generating function out. You don't need to prove the moment generating function. for this. Does that make sense? You do not need to prove. Okay, now, and I'm gonna give you a moment generating function of a distribution. It could be any of that, and I ask you to find the probability or something like this. Okay, so please take notes. Now I'm done with the moment generating function.